Good morning, everybody. Welcome to another wonderful morning at Chem's 11:05 with your host, me, Dr. White. All right, important things. First of all, I know some of you couldn't make it to class yesterday because of the massive Comcast outage in the, I guess, DuPage County area. I know the actual main campus, COD, was affected, and because of that, you couldn't, even if you had internet, if you hadn't downloaded my syllabus and you just go to Blackboard, you couldn't get into Blackboard. Good news. Yesterday's lecture is already up on my YouTube channel. You can find it, the link to that, in my syllabus, or B, go to YouTube and put in CHEMI 1105 WHITE, White, and it will take you to that YouTube channel. All right, important other information. Friday, I will be giving test number 3 during the lecture, and the way I'll do it, just like I did 1 and 2, I will be sending out a little before 10 a.m. on Friday an email with the password that you will use to take your version of test number 3. There are 2 versions. I think it's G and T. I'm using letters of the alphabet. You'll have from 10 until 11:30 to take test number 3 and upload your test answers as a single PDF file. I'll have the instructions like I did before on the other tests and I do on the lab, how to do that in case you forgot. Now, one thing I forgot to do last test, and I'll do it right now, and please don't raise your hands or anything. If you are a blue card student, a special needs student, you will have all the extra time you need, and I'll try and send out emails. Now, another important thing, as I mentioned earlier, next Monday, I'm going to have cataract surgery on my eyes. I'm still nervous about it, but I have a good surgeon and good blueberry tea, and all should go well. But it's going to be, I have to be there, and I won't be able to teach class because I have to be there at 11, and it's a half hour from my house. And there just won't be a lecture on Monday. What I will do sometime, hopefully Sunday, is I will post on my YouTube channel a video of the material that I would have gone through on that Monday. I will not go through the test answers on that Monday, but God willing, and I hope he is. But anyways, on Tuesday, I'll go through the test answers for test number 3. I guarantee by Sunday, 1 p.m., I will have posted your test scores for test number 3 in Blackboard, and I'll also emailed to you your points you received for each answer on test number 3. So I think that takes, one other thing. Yesterday when I did the lab, and I knew about it beforehand, there was a bug in the software for the sodium hydroxide standardization Beyond Lab Z lab. And yesterday, because I know some people at Beyond Lab Z, I reached out to them and they confirmed, yes, that is a problem that I had. They had the same one, and they're going to try and fix it as soon as possible. So if, I don't know how soon that means. So if you are doing that lab, and when you turn the stopcock open and you see liquid coming out of the tip, but the level of the burette doesn't change, hit reset, which is in the lower corner right down here of the window for Beyond Lab Z, and then just redo the lab, pick the NaOH standardization, just like I did yesterday. If you're unsure, look at the video. All right, Amber, try backing out back to the main screen, opening it. Maybe that's because they're playing with it playing with it, trying to fix it. Anybody having problems with that lab, let me know tomorrow morning via email, and I'll reach out to the people at Beyond Lab Z. One of the people I know is a very senior person in the company because I'm trying to get them to work with me on new projects. So I know them. I also have met with the CEO of that company. So I'll be able to see if I can fix it. So Amber and anybody else, first of all, Amber, thank you for giving me that feedback. I appreciate it. Let me know tomorrow or Friday morning or whenever, send me an email and I'll reach out to them. You may have to reset it a second time and wait about 20, 30 seconds. I don't know, try all those. That's what I would do. All right. Today I promised I would do my world famous review for the next test, and that's test number 3. So let's get to work. And by the way, what you're seeing right now is available in the lecture section folder of Blackboard, secretly named Chem 1105 test number 3 review. All right, first of all, we started out with chapter 6, gases. And the first thing you should know is pressure. And there are 2 key things you should know. 1 millimeter of mercury, Hg is mercury, is 1 torr. And I didn't fix it in here in the review. I'll get it sometime. But anyways, 760 torr. 760 torr equals 760 millimeters of mercury equal 1 atmosphere. Now, I would like to remind you that before you take test number 3, you go to the lecture folder, and I have the folder secretly named important information test number 3. And I don't have it in the right order, but if you notice, I have 760 torr equals 760 millimeters of mercury equal 1 atmosphere. Now, a skill you should have for test number 3, as seen in the practice problems here, like number 5, how many millimeters of mercury is so many 4.564 times 10 to the 3rd atmospheres. You're trying to find millimeters of mercury, you're given atmospheres. Use your good buddy, your good friend, unit analysis, and here, atmospheres. You want to go to millimeters of mercury, use a ratio to convert it. What goes on top of the ratio? Millimeters of mercury. What goes underneath? Atmosphere. Where do we get these numbers? In case you didn't memorize it, which I'm no longer forcing you to do, if you look at important information, test number 3, 760 millimeters of mercury equal 1 atmosphere. This is a definition. These numbers, 760 and 1, are exact numbers. And therefore, if you notice, we start out with 4 significant figures. These are exact numbers. We end up with 4 significant figures. One thing I'll remind you, on test number 3, like test number 2, it will say underneath your name, and please print and sign your name. It will say, first, please use proper significant figures for all calculated answers, and please use 3 significant figures for all atomic masses. I'll be providing the green periodic table. Oh, don't you love that blueberry tea? You're missing out on a lot. But anyways, that we've used all semester. And if you don't round it off properly, I'll take off a point, which I've been doing all semester or first two tests. And that's how you do that. Let's move on. Now, in gases, you will need to know how to convert from Celsius to Kelvin. Here's the formula. Guess what? No, you don't have to guess if you don't want to. In important information, I give you that formula. So you should know how to use it. Next, we talked about, notice how I say we, I talked about, you listen and learn, which is a good thing, about Boyle's law. They're gas laws that help us understand the relationship with different physical properties of gases. And Boyle's law is P1 times V1 equals P2 times V2. And P1 is the initial pressure, V1 is the initial volume, P2 is the final pressure, V2 is the final volume. And if you look at important information, test number 3, I give that to you. Boy, I'm being too nice to you people. I got to change my good habits. No, I won't. And if you look to the review, if we look at number 7, if a piston has a volume of 22.4 liters at 12.34 atmospheres, what is the volume of the piston when the pressure is reduced to 3.567 atmospheres? Now, if you look at this problem, first of all, you should determine what are you trying to find? Well, a volume after you make a change, and that's V2, a final volume. You're given initial volume. Remember, L, liters is volume, atmospheres is pressure. So you're given initial pressure, volume, and you change it to a final pressure. And when you see a problem with gas, and if you see a piston and pressure and volume, that's gas, that's Boyle's law, which you have in important information test number 3. So P1 times V1 equals P2 times V2. We want to solve for V2. When you want to solve for V2 or anything, you want it alone on one side. Well, when things are multiplied, how do you get rid of something you don't want? You divide by it. Anything divided by itself is the number 1. I like these special visual effects I'm using, not. But anyways, P2 over P2 is 1. 1 times V2 is V2. But whatever you do, and this is something students forget, so don't, that's why I'm telling you, you do to the other side, which I did. And you get V2 equal P1 over V1 divided by P2. All I've done is rewrite it, because I like to do that, and good habits I don't change. And now, since we took the time to figure out what P1, V1, and P2 are, I put it in there. Notice atmospheres divided by atmospheres cancels out. The only unit you're left with is liters. Guess what? That's volume. And let's look at this. Notice this is 4 significant, 3, 4. When you multiply and divide, you get the same number of significant figures in your answer as the numbers you're multiplying and divide that has the fewest significant figure. Well, you got a choice, 3 or 4, and time's up. Hopefully you all pick 3, and you round it off to 3 significant figures. Next is the ideal gas law, PV equal nRT. And P is pressure, and it's important to know it has to be, these different variables have to be in the correct units. You'll have pressure has to be in atmospheres, volume has to be in liters. By the way, I'll be nice. I'll always give it to volume in liters, or if you have to calculate it, it will be in liters. N is the number of moles. T is temperature in Kelvin, and R is the universal gas law constant, 0.0821 atmospheres liters per mole Kelvin. And notice this is 3 significant figures. Please don't go out into the internet and find one with 10. I'm going to mark that whole problem wrong because I know you went out into the internet, which you're not supposed to do. By the way, I'm saying that because I caught 2 people doing that last semester, and they were penalized for cheating, because you're not supposed to go on the internet to find things like this. I give it to you. And to prove that point, if you look at important information, here's the ideal gas law. I give you all this too. Am I nice or what? But anyways, what I really am doing is testing your knowledge of chemistry, not your memory. I'll leave that to other classes, or even is that supposed to be done? All right. Let's look at a PV equal nRT problem. We look at number 11. A tire contains 25.67 grams of nitrogen gas, N2. See how nice I am? I even give you the formula for nitrogen gas at 26 degrees C and 705 torr. What is the volume of the nitrogen gas in the tire? Well, you're trying to find volume V. You're given a weight, you're given a pressure, you're given a temperature. And it's also 15 points. 15. But anyways, as soon as you see a problem with gas, and nitrogen gas is a gas, and nothing changes. Notice none of the variables change. That tells you it's PV equal nRT. What do you want to solve for? Volume. What do you have to do? Get rid of the pressure. How do you get rid of something multiplied times something else? You divide by it. So if I divide pressure by pressure, that becomes the number 1, which 1 times V is V. But whatever you do to one side, you have to do to the other, which I did, divide by B. So to find volume, we have to use nRT divided by B. However, we don't have the right units for N, T, and B. So we have to convert them. N is moles. We have grams. We have to go to moles. How do we do that? Use your good buddy. Where was my mind going? All right, let's try this again. And I'm going to sneak this in. Use your good buddy, your good friend, unit analysis. Love that whistle. Just think, at the end of the semester, unless you come back to my YouTubes, you won't have to suffer through that. All right. How do you use unit analysis? What the units you're trying to get to go on top of this ratio. Units you're trying to get rid of go underneath. Where do we get a relationship between moles of a compound and grams of a compound? Well, in case you forgot, we go to test number 3, and where did I hide it? Oh, this is the review. Wrong thing. We go to important information, test number 3, 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic count weights in that compound. Let me say that again. 1 mole of a compound equals the molecular weight of that compound in grams, And now you need the molecular weight, because I'm not going to give it to you, I mean, the molecular weight of a compound is the sum of all atomic weights, which you get from the periodic table. So if we go there, 2 nitrogen atoms in nitrogen gas, N2, each nitrogen to 3 significant figures has atomic weight of 14.0. And 2 is an exact number, so you get 28.0, 1 mole per 28.0 grams. 4 significant, the 1 is exact number. We have here 28.0 is 3 significant, so the answer is 3 significant figures. Now, this is a multi-calculation problem or multi-step, however you want to view it, and you can round off at the very end or each step. I'm a round off at each step person, but I will calculate it both ways, and if the answers are not the same doing both ways, either one will be correct on test 3. Now, next one, pressure is in torr. I've never seen a gauge in atmospheres. I don't think they exist, but for PV equal nRT, and this is a common mistake students make. Listen, this is a common mistake students make. They use pressure to torr or millimeters of mercury. No, you've got to convert it into atmospheres. And remember, important information, test number 4, it says right here, pressure in atmospheres. So, and we've done this earlier, here's torr, we want to get the atmospheres. Where do? We use unit analysis, atmospheres goes on top, torr go underneath. I mentioned it earlier, and you saw that in important information. 1 atmosphere equals 760 torr. These are exact numbers, so this is 3 significant. Your answer should be 3 significant unless you're rounding off at the end. And finally, temperature is supposed to be in degrees K. Another common mistake is students put this right in 26.0. No. If you look at important information, test number 3, T, temperature in Kelvin. So you have to convert it. And in case you forgot, here's the formula for it, and important information, test number 3. And 26 plus 273 is 299. I want to find V. Also important information, R is given. So I put in moles, R, temperature, atmospheres. This is all 3 significant figures. And notice your answer you get is 24.3 liters. And if you round off at the end or at each step in this problem, you get the same thing. All right, Dalton's law of partial pressures. Remember, P total, the total pressure of a gas is equal to the sum of all the partial pressures of the gases in a mixture of gases. Now, we also talked about boiling point of a liquid is when the vapor pressure of a liquid equals atmospheric pressure. Well, the higher you go on our planet, unless you're following me from another planet, which probably is still true. Anybody coming, watching me from Mars or Venus or, I don't know, Neptune? How about Pluto? Oh, wait, that's no longer a planet. All right, the higher you go on the altitude of the Earth, the lower the atmospheric pressure is. And because of that, you need less energy to have the vapor pressure of the liquid you're boiling equal atmospheric pressure, therefore, the lower the boiling point. So if you go up to the top of the Himalayas, what happens to the boiling point of water? It's way down because of lower atmospheric pressure. All right, next I started talking about solutions. Solutions is when you have one compound homogeneously dispersed in another compound. And a solution, key terms are the solvent, and a solvent is a component of a solution present in the greatest amount. And all the other components are called solutes. Now, something that you might think looks like a solution, but it's not, is called a colloidal dispersion. And a colloidal dispersion is a special type of mixture that particles are suspended in the liquid, and it's not a true solution. How do you know that? It scatters light. Oh, it's time for Dr. White to play with his flashlight. And if I had sugar and water in there, I don't, but if I did, oh, look, the light goes through. If this were milk, assume it's milk, oh no, the light doesn't go through. And other examples you should know of colloidal dispersions are latex paint, I already said milk, mayonnaise, ketchup and mustard. You can, next time you're with friends at a restaurant, and they're putting ketchup or mustard on something, you can tell them, you know, that's colloidal dispersion and it doesn't scatter light, or does scatter light, excuse me. But if they're drinking Dr. Pepper, that's a solution. I'm a pepper guy and also like Verner's. Ooh, this is another solution. Gee, good solution. All right, now, what I don't have down here, you should know what a concentrated solution is and what a saturated solution is, what a dilute solution is, and what, I think I covered everything, and also what an aqueous solution is. By the way, aqueous solution is where the solvent is water, and it's shown by bracket AQ, close bracket. Now, one of the more important things, we'll come back to this later when we go through organic chemistry in this class, the fun part. I'm an organic chemist, so I'm biased, but like dissolves like. And that's like solutes are soluble in like solvents. And that means polar solutes are soluble in polar solvents, and nonpolar solutes are soluble in nonpolar solvents. If you mix two together, they're not soluble. Oh, I do have the definitions here, but I don't have this, which I'm going to make you memorize just a little. Things that are polar, you should know water is the most polar thing. Next, any salt, such as please pass the nickel, and other salts. And alcohol is polar. There are other things, but for this class, and nonpolar, things that are nonpolar would be, oops, I promise not to write, vegetable oil, any vegetable oil, peanut oil, vegetable oil, olive oil, all those oils are nonpolar. Gasoline is nonpolar. Vaseline or petroleum jelly is nonpolar. Baby oil is nonpolar. And we'll learn later on other things like grease and dirt are, but for now, you should know this. And if I take vegetable oil and water and mix it together, they'll separate because like dissolves like, this is polar, this would be nonpolar. Now, if I take water and sodium chloride, an example of an alcohol you don't think about, but sugar is really an alcohol, but not the type of alcohol that gets you inebriated. If you sit and drink, eat a lot of tablespoons of sugar, you're not going to get inebriated, even though I'll show you later why it is really an alcohol, but not the type you're thinking of. Sugar is soluble in water, and that's like dissolves like. And remember, the solubility of the solid is the maximum amount of a solute that will dissolve in a given amount of solvent. If you put one more molecule past the solubility limit or the solubility weight, guess what? It will precipitate out, form a solid at the bottom of the container you're having. Now, saturated, same thing. You can saturated as well is the maximum amount you can put in. If you put one more molecule, guess what? It won't dissolve. Dilute means you have a small amount of solute relative to the amount that could dissolve. Concentrated means you've got a large amount, but you're not at saturated yet. Actually, saturated means you have more than the maximum amount. Or I have it right here. Solubility, saturated, you are at the maximum amount. Oops. Next, we talked about different ways of measuring concentration, like percents by weight, percent by volume, which will not be on test number 3. But the most important is molarity. Molarity, which is shown as a capital M of a solution, is the ratio giving the number of moles per liter of solution. But 1 liter equals 1,000 milliliters. So the important part is molarity equals moles of solute per 1,000 milliliters of solution. Wow, very important. Know this. I guess you better follow what's on the screen. And if you look at important information, test number 3, I have molarity equals moles of solute times 1 divided by 1,000 milliliters of solution. And notice in chapter 5, part 2, practice problems, which I give you the solutions. Actually, I do give you the solutions like Bob. Never mind. Oh, that was a bad joke. Sorry. But anyways, you should know examples of colloidal dispersions, of solutions, how to determine which is a solvent, which is the solute of a solution. We've gone through this. You should know, what does capital M mean? Capital M, I can't do it on a PDF file, means moles of solute per 1,000 milliliters. So when I ask what is 1.34 capital M, HCl means hydrochloric acid. That means 1.34 moles of HCl per 1,000 milliliters, because the molarity, capital M, tells you this is molarity. And if I ask you, what does this mean? 4.56 times 10 to the third molarity, capital M is molarity, capital M NaCl, bracket AQ, close bracket, mean. And what is, now I'm getting really serious, what is the solvent of the solution? You should know capital M, molarity, moles of solute per 1,000 milliliters. So it's 4.56 times 10 to the third moles of sodium chloride per 1,000 milliliters, and bracket AQ, close bracket, which stands for aqueous, tells you, comes from the word aqua, water, in Latin, and I believe also in Spanish and other Hispanic languages, is solvent is water. Now, let's look at a problem using that. how many moles of sodium chloride are in 125 milliliters of 3.45 molar or NaCl solution, capital M, molarity. Well, what are we being asked to find? That's the first thing you should answer. Moles of sodium chloride. What are we given? 125 milliliters. What are we also given? The secret number, 3.45 capital M NaCl. No, it's not a secret. Capital M molarity, moles of solute, in this case 3.45 moles of sodium chloride per 1,000 milliliters. And if we look at how do we proceed, the only number we really have is 125 ml is milliliters volume. We want to get the moles. We'll use the ratio. And how do we fill that ratio to convert from milliliters to moles? We use our good buddy, our good friend, unit analysis. Anybody keeping count of how many times I say that? So I want to get the Guinness Book of World Record for saying that most times in one semester. And moles of sodium chloride goes on top, milliliters go underneath. That's how you use unit analysis. And where do we get this number? Because we knew 3.45 capital M NaCl is moles. And I see a question, I didn't see that. All right, I'll talk to you, Spencer, and anybody else about what 3 times if you're still having the bug after class. Ooh, teacher wants to talk to you after class. No, it's a good thing. All right, so notice milliliters divided by milliliters, and that becomes number 1, it's gone. 3 significant, 3. The 1,000 is an exact number. Therefore, my answer is 3 significant figures. Oh, thank you. I just had a brain freeze. Thank you for clarifying that. By the way, you could have put down your good buddy, your good friend, unit analysis. I'm just kidding. All right, thanks, Spencer. All right, now, while talking about molarity, important what would I call it? Important procedure you do a lot of times in a lab or even a chemical plant is make up a certain molar solution of a compound. And therefore, you have to know how many grams of a compound you need to make a certain amount of a certain molar solution. So if we look at 12, how many grams of H2SO4, sulfuric acid, are needed to make 345.5 milliliters of a 6.77 times 10 to the minus 2 capital M H2SO4 sulfuric acid solution. So what are we trying to find? Grams of sulfuric acid. We're given milliliters, and we're given this number with a capital M and a compound after it. What is that? Molarity. And you know that means 6.77 times 10 squared moles of H2SO4 per 1,000 milliliters. Now, can you go from milliliters directly to grams? No, there's no way. So if we look at important information, test number 3, you'll see molarity 2-step. First one, go milliliters to moles, and then moles to grams. Now, how do you know to use this? Good question. Thank you. Well, what are we starting with? Milliliters. What are we ending up? Grams. So that's how you know to use the 2-step. And you're given this. I'm being way too nice. So step 1, we want to go milliliters to moles. And what do? we have 345.5 milliliters. We want to get the moles of H2SO4, sulfuric acid. Use your good buddy, your good friend. Does that make it 4 now or 5? But anyways, don't forget, I'm asking for the whole semester, not just today. You use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. Notice milliliters divided milliliters cancel out, and we're left with moles. Where do we get these relationship of milliliters to moles? From over here, what the molarity means. And remember, this is 4 significant figures. 3, 1,000 is the exact number. When you multiply and divide, ignoring the exact numbers, you don't use those. The number that has the fewest significant figures is how many significant figures your answer should be. So that's 3. Now we have moles of H2SO4, but we're trying to get the grams of H2SO4, sulfuric acid. Therefore, we use step number 2, which is, as you saw, an important information, test number 3, going from moles to grams, which we practiced yesterday. You didn't see it, watch the video. And we did this earlier too today too. Here I have how many moles of H2SO4. I want to get the grams of H2SO4. How do I proceed? Use your good buddy, your good friend, unit analysis. The units you're trying to get to go on top of this conversion ratio. The units you're trying to get rid of go underneath. Where do I get the relationship between 1 mole of a compound and its weight of a compound? In case you forgot, you look at important information, test number 3, 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound in grams is the sum of all atomic weights. And therefore, what's the molecular weight of H2SO4? 2 hydrogens, 1 sulfur, and 4 oxygen. The atomic weight of hydrogen, the 3 significant figures, 1.01. Sulfur, 32.0. Oxygen, 16.0. Remember, these are exact numbers, and that's a mistake. That should be 2.02. Sorry about that. I did make a mistake, but not in the molecular weight, I believe. Nope. It actually should be, I think I did make a mistake. That should be 98. So this is going to be a slightly different. Oh, there goes my perfect score. But anyways, that's how you would do it. And if you did make a mistake like this, where I saw this, it pays to show your work. Because if this were a 10-point problem, and I'd only take off 1 point, because I could say, oh, you made a mistake here. That's just a math error. So I'm not going to take off a lot of points, just 1 point. And that's how you do that. And the only thing I didn't talk about, which I should remind you because winter's coming, and that's, remember, let me check everybody can see my whiteboard. And you can. Remember, PV equal nRT tells you when to check your tires. In the winter, which is coming, like tomorrow is supposed to, they're talking about snow for Friday, light snow. The temperature goes down, therefore PV equal nRT. These are all fixed, do not change in your tire. If the temperature goes down, then the pressure has to go down. So in the dead of winter, keep an eye on your tires. In the summer, luckily we didn't have too hot of a summer. Temperature goes up and the gas in your tire, air or nitrogen, depending on which you fill it with, I use air, these still will be constant. the temperature goes up, the pressure will go up. And you should know this. And that's my review for test number 3. Now, we still have a couple minutes left, so I thought I'd tell you a nice true story. I don't tell any false stories. I don't know why I have to say true. When I first bought this house I'm living in, a couple weeks after I moved in, my kitchen sink stopped up. I'm saying, oh, the last owner must have poured a lot of grease or oil or other things down the kitchen sink. So I figured, I don't know how stopped up it is. Let me get someone to root it out and clean it out. So the guy came out, did it. And about a week and a half later, stopped up again. And guess what? I called him back because there was a 6-month guarantee. And he apologized, did it again. And within a week or two, did it again. Now, I was working full-time at a chemical company as a senior manager, so I was paid a yearly salary, not hourly, but I was still missing work that I had to get done. So he came out a third time and said, oh, I apologize, and he routed it out. And he also put this product in there. This will clean it out too. And I looked at the label, being an organic chemist, and I said, no, this won't. So within a week or two, it clogged up, and I'd wasted enough time waiting for him to show up and everything. So I went over to my local Home Depot, and they have some nice people there. And I went to the area where they had the drain cleaners. And there's this big wall about 6 feet wide, shelves 5 feet high, all these different products. I picked up 1 or 2, and I saw, because I'm an organic chemist, I'm a chemist, they had things like either hydrochloric or sulfuric acid. And I'm looking, what do I buy? And this nice gentleman who worked in that area came up to me and said, can I help you? I said, sure. And sometimes my brain works on a really good level. I said, all these drain cleaners, which one did the plumbers use? And quicker than you can snap your fingers, he pointed to one product and said, that's what they use. And what's that one product? And I don't get any kickback. And it's called hair and grease drain cleaner, drain opener, hair and grease. And it comes in different size bottles. I keep actually a quart in my house all the time. And I looked at the back of the label, and here's the funny part. And it said potassium hydroxide, sodium hydroxide. I looked and said, oh, this is a base. And the guy said, no, it's an acid. I said, no, I'm a PhD organic chemist. I know acids from base, and this is a base. Sodium hydroxide is base. I said, no, it's an acid. And all of a sudden, my brain back here kicked in and said, why are you arguing chemistry with someone who doesn't know the difference between acids and bases in Home Depot? He helped you out. I took it home, worked like a charm, followed the instructions. Since then, I've used it twice, once about 10 years later in that sink. And about 6 months ago, in my bathroom sink up here, it clogged up, used it, clean as a whistle. I've had many students use it, and my brother-in-law used it in their house, and everybody's ever used it. That is a great product. Follow the instructions. They also tell you wear safety goggles, which I did. And I wore a long sleeve top, so if anything splashed on me, which it didn't, but still, it wouldn't get on my skin. I wore rubber gloves. And with that, oh my goodness, I'm done for today. We're out of time. Remember, Friday, I'll be giving test number 3. We will not have a lecture. Next Monday, and I'll send out an email on Saturday or Sunday, we won't have a lecture because I'm undergoing cataract surgery. But I will post a video for that lecture. Tuesday, I'll go through the test. By Sunday, I'll get everything out. And with that, don't forget, tonight, Spencer just asked today's video, I will have by tonight or sometime later this afternoon, because I teach this afternoon. But I would hope by 5 p.m. I'll have this so you can go back and watch it. It'll be available tomorrow. Friday during the test, I'm going to shut it off because I don't want to tempt anybody to go and look at it. And with that, I'm going to say sorry for running a whole minute late. Oh, but anyways, gang gesund. Bye now. I'll see you either tonight in my office hour or next Tuesday. Bye. Don't forget test Friday, and there'll be a YouTube for next Monday. Bye now.